Hey, 8th grade, this is lesson 8.5 with my fully functioning, okay, not quite functioning voice. This is distributive property. And this gets you into factoring some of this stuff, is really what they're talking about. So that's what you see right here. And this is on some page. What page number is this? For you to follow along. 497. So we'll go through a lot of these possibilities here and see what you think. Distributive property, factor each polynomial. So you have to look at each part and decide what do they have in common. Well, this one here, number one, doesn't have any variables in common, but they both do have 3 in common. There's a 3 and 21. There'd be 7b and then minus 5a. And that, of course, would have out in front of it 3. Where'd my 3 go? There it is. 3. So that is how you're going to factor that. And that's what they want you to do for that part. So if we go to one that's a little harder, number 4, let's see, everything here has a 2 in it. So I'm going to factor a 2 out first. And it looks like everything has a J and a K. But not everything has 2 J's or 2 K's. So J, K, J, K. And okay, so now for each part, when you figure out what they have in common, the first one is going to have the 6 is still there. The J has been factored out, and there's still a K left. And then there is, in the next one, there's 3. 2 times 3 is 6. And we're taking out a J and a K. So there's still a J left, even though K is still there. Then the last one, the 2 is gone, and a J and a K, but there's still a J, K left. Any questions on that? Great. Let's keep moving. Hopefully that all makes sense. Look for what they have in common. Now, on the next part, they talk about factoring each polynomial. And whenever there are 4 parts, you should look and see, are there 2 parts that have something in common? So like for these two, if I kind of draw lines down here, to say you're going to look at the front part and the back part and see if there's something that you notice that they have in common. So, for example, in number 5, the first two, the np plus 2n, there's an n in both. And that would be n times p plus 2. Because I factored the n out over there. Oh, cool. Step-by-step solutions. How nice. I factor out the n there and the n out of there. So all you have left is the p plus the 2. On the other one, it looks like there's an 8 in both. So I know that would be 8 times, and I think there's going to be a p left in the front, and then plus 2. And so what you should notice for each of these is that you should end up with something that matches. Because now what you have is you have n plus 8 times p plus 2. Like that. And if you would go back and do the FOIL method on this, you would have the n times the p. Guess what? That's np. And then if I have then the 2 times the n, gives me the 2n. Then I do 8 times p, 8p, and then 2 times 8, 16. So there you go. That is how that works. Let's look at another one. Look at number 7. So in this one, the only thing these first two have in common looks like b. So I'm going to put b over here just because that's where I have room. And if I take the b away, I'm going to have 3c, and in the minus 2. Okay? Now in the second one, they both have 5 in common. And if I take 5 out, let's see, 5, I'm going to have negative 2 and I believe I'm taking the 5 out of 3C. Now, are those the same? B times 3C minus 2 and 5 times negative 2 plus 3C. Those are the same because you could just rewrite this one as 3C minus 2. There you go. And so then again, that would be B plus 5 times 3C minus 2. Now, again, if I do the FOIL method, I like to do the first ones first. So 3C times B would be 3CB. And then I like to do the last. Negative 2 times 5, that's negative 10. That's negative 10. Ooh, that looks like a 16. Let's make that a 10. I'll just scribble enough, it'll look like a 10. All right, then I'm going to do the inside and the outside. Wait, Floyd, outside first. Negative 2 times B, that's negative 2B. And then 3 times 5C, that's the 15. 15C. Let's make sure everything matches. I have a 3BC. Yep, I have CB, but same thing. Negative 2B. Yep, I have a negative 10, and I have 15C. It's all there, and just the order doesn't matter because commutative property. All right. I'm going to assume you'd like to see another one. Anybody not want to see another one? Great, didn't hear anybody. So number 6, the first two are right here. Looks like they have an X in common. And I'm pretty sure if I take the X out, I end up with Y minus 7. And on the other one, if I take, we'll see, they don't have a Y in common. They'll both have 7. If I take the 7 out, I'm going to end up with Y minus 7. Okay, so X plus 7 times Y minus 7. There you go. And what about number 8? Okay, so now these two in the front both have a 9 in common and an F. So 9F times, okay, now that's only going to have a G left, minus 5. Make sure I did that right. Looks right. The second one, now you can start thinking, okay, I really want to get a G minus 5. A G minus 5, which means I really want to factor out not just a 7 from both, but a negative 7. So now I can have negative 7 times G, and negative 7 times negative 5 will give me the positive 35. So for this one, you get 9F minus 7 times G minus 5. And there you go. And you can do the FOIL method to see if it works, but it does work every time. Now, the next part here says, I must have reached the bottom of the page, says, check each solution. Check your solutions. Or I'm sorry, it says solve each equation. So some of these are pretty straightforward. And like on number 9 here, you have 2 parts already. You can just set each part equal to 0. So 3k equals 0 and k plus 10 equals 0. So what is that? Is that a plus? Wow. Now I'm pretty sure over here 3k equals 0, that k is going to equal 0. And over here, k plus 10, I'm pretty sure that k equals negative 10. So 0 and negative 10. So if I do this, nope, no, let me do that. Erase. And if you want to see, if you put 0 in here, 0 in for k, you get 3 times 0 is 0. Well, 0 times anything is going to be 0, so that one works. The negative 10, though, you would have 3 times negative 10. That'd be negative 30. negative 30 times, let's see, negative 10 plus 10, that's 0. So that'd be 0. So that one works. Now, on other ones, like number 10 here, you would just have to do 4m equals plus 2 equals 0. So I could take a shortcut and say 4m equals negative 2. And the other one that I would do would be 3m equals 9. You know, I'm going to tell you that it's going to say m is, this one, m is going to be 3. And up here, I'm pretty sure m is going to be negative 1/2. All you have to do is put them equal to 0. Now, 11 and 12 give you a little bit of a different twist. Because on 11, you know, there's no easy thing here to look at. You don't have two things being multiplied unless you do the factoring, which is that next goal. So if I look at each part, I have, they both have a 5 and they both have p. So I'm going to have 5p on the outside. And if I factor that out from the first part, it'll be 4p. And then take 5p out of the second part, and it's going to be minus 3. Now I can set each of those parts equal to 0. So 5p equals 0, and 4p minus 3 equals 0, or in other words, 4p equals 3. This one up here, p equals 0. Down here, p equals 3/4. Same thing on the next one. First thing that you need to do on this, r squared minus 14r. You have to get everything on one side with 0 on the other, so that you can now factor and have r times r minus 14 equals 0. And I hope if you look at this, you can see that r is going to equal 0. If you set it equal to 0, and then set this inside equal to 0, and you're going to get r equals 14. So r equals 0 and r equals 14. Those are your two answers. Hopefully that makes sense. Let me take a quick look here. I'm going to pause. Okay, so now on this page, the assignment page, going, you know, these are just like the ones we just did. Where'd my pen go? Blue. All right, so these are just like the ones where you just have to factor it. That's all you have to do on those. And these, you know, for each of these, you're just looking to see what each part has in common. It's when you get down to these where you have to look on all of these at, you know, what does each half have in common? And I'm looking for some tricky ones, and I don't know that there are any really tricky ones on this yet. Down here, it's like, you know, like we said, number 40, you would set 2n equal to 0. I'm pretty sure that means n is 0. And then 3n plus 3 equals 0. I'm pretty sure that 3n would equal negative 3, and then n would equal negative 1. So there you go. And then I think I have a few fun ones for you to deal with. The fireworks thing here gives you a formula just like that. And this is things being fired from ground level. All right, well, this comes up over and over and over. T is the time in seconds after launch from ground level. And this is write the expression that represents the height in factored form. So that one, you're going to factor that, and you're going to look at these, and you're going to say, actually just this part here, and I'm pretty sure that they both have a T in common. So I don't know that 263, 16, I don't know that 16 goes into 263. Anybody checking that while I check it? Raise your hand if you have the answer. Come on, somebody has to know this. No, it doesn't go in evenly. So you would end up with, for this, the factored thing would be T times 263 minus 16T. Right? Okay. at what time will the height be 0? And then you have to figure out what the height will be when, or I'm sorry, what the time will be when the height is 0. So guess what? You have to set this equal to 0, and you can set each part equal to 0. Now, if you look at this, if I draw my thing here, and saying, because you're saying height is 0. Now, if you set each part equal to 0, you're going to get t is 0. At time of 0, does it make sense that the height would be 0? Which it should, because that's where it starts. At time 0, the height is 0. It's shot from ground level. But there's another one. You got to set this one equal to 0. And I think you're going to get 16t equal to 263, I think. And then you divide that out, and you'll get the time it's going to take for it to get back to the ground. What is the height of the shell 8 seconds and 10 seconds after being fired? All right, well, that's not too hard, because if you have your formula, or this formula, you put 8 in there, you put 10 in there, and then you'll be able to figure out what the height is. And then you should be able to tell if it's a rising or falling too. Hopefully that all makes sense. I think I helped you way too much on that one. Oh, I got to go to the next page. Where is 48? Hey, guess what? Here is the height of a rider being dropped. That can be modeled by this. Height of a rider being dropped. What does that mean? Where h is the height in feet and t is the time in seconds. Write an expression to represent in factored form. All right. So in factored form, excuse me. Let's see. I'm taking a wild guess that 16 goes into each of those. I know 16 goes into 16 and 160. I'm pretty sure 96 divided by 16. So you can take a 6 or a 16 out of each of those, and you're going to get negative. Wait, where's my pen? Wait, don't turn the page. Your pen goes away. So I'm going to get h equals 6 times, and then let's see. 16, that's supposed to be 16. Yeah, I'm aware of that now. Negative t squared. And let's see, that's where I need my negative 6 and plus 6, negative 6t plus 10. So there is the factored form, or should be the factored form. Let me just double check, see if that's what they want. So what I was looking for was to see if this factored form is right, or if they factored out the negative. So everything's good. So that's the factored form. So then it says, from what height is the rider initially dropped? And let's see. When the rider was initially dropped, right away, the time should be 0, correct? If you think about it, you're initially dropping this rider. This is like an amusement park ride, bungee jump or something, or just some way to scare somebody to death. And time 0 is when you are initially dropping them. So guess what? You're going to put 0 in for t for the time. See what you get for the height. That'll tell you. And then again, at what height will the rider be after 3 seconds of falling? Is this possible? So 3 seconds of falling, see what height it is, and is that possible? And then explain why not. And then the last one is 50, which is tennis player. You have your equation there. Ignoring the height of the tennis player. So that's just because you don't want to have to think about, just figuring that in. Time in seconds. How long does it take the ball to hit the ground? So in other words, what they want to know about this right here is, when will the height be 0? And I would start by factoring it out and seeing, what do 80 and 16 have in common? They obviously have a t in common. You can factor a t out. Gosh, I wonder if they have a 16 in common. Let's see. 16 times 5. That's 30. I don't know. So there you go. Some hints for you. That's what it is. I think the whole assignment I just gave you was starting whatever up to 50 even. There you go. You can email me. I will have time to answer questions through email. You could even email me right now at the end of this video, because I'll be sitting there listening to people talk, and I'll want nothing better to do than to answer emails from you. So there you go.